All right, welcome back to Inorganic TUTOR'S Institute. In today's powerful lesson, we are going to continue with the coordinate geometry that we started in lecture 1. Okay, so basically this is going to be lecture 2. Okay, so what is it going to entail? We are going to cover angles between two lines, and also we will talk about the division of a line segment in a given ratio. Okay, so let's begin with the angles between two lines. Okay, so basically consider two lines. Okay, let's say line 1, L1 and L2. Okay, and these two lines have gradients M1 and M2 respectively. Okay, so with these two gradients, note that M1 is greater than M2 and these two gradients are greater than 0, meaning they are positive. Okay, so let's look at this illustration. Okay, so let's illustrate the angles between two lines on the two-dimensional plane, okay, or what we call the S and Y plane. So we have our y-axis and our x-axis, right? So this is what we have. And let's say we have line 1 that is drawn at this position. So we call this L1. And there is another line, okay? There is another line that joins L1. So we call this L2, okay? And this is our L1, right? So we want to know the angle that forms here, right? That is between L1 and L2. So we call this theta. And don't forget, this is a straight line. So every straight line forms an angle of 180. On this straight, there is an angle 180. So we want to know this section as well. So we have 180 minus this theta, right? And then let's label this section alpha, label this section beta, and label. Okay, so basically we have all the sections labeled. We are interested in this angle, right? So you know that the sum of these angles here, these three angles, must be equal to 180 because they are in a triangle. So we sum beta plus lambda plus theta, and that must be equal to 180 degrees, right? So let's try to make lambda the subject here. So making lambda the subject, we're going to have 180 degrees minus beta minus theta. So we consider this as equation 1, right? Now, you know that the sum of this interior angle and this exterior angle must be equal to 180, right? So that is a property in theorems, right? So lambda plus alpha must be equal to 180 degrees, right? So making lambda the subject here, then we're going to have lambda equals 180 minus alpha. So we consider this as equation 2, right? So having equation 1 and equation 2, then we can say that equates 1 and 2, right? So in doing so, we're going to have 180 minus beta minus theta equals 180 minus alpha, right? So once you have this, you know that this will take all of this, right? Because when this comes here, you're going to have 0. So the 180 goes off. So we're going to have minus beta minus theta equals negative alpha, right? Don't forget, we are interested in the theta, right? So we are interested in this angle. So we're going to make theta the subject. So negative theta equals negative alpha plus beta, right? So let's try to make this one the subject, making it positive, right? So if you try to make that one the positive, then we're going to have negative theta equals alpha plus beta, right? So basically, we divide through by -1. So we're going to have -1 here, -1 here, -1 here, right? So we have this going off. So we have going to have theta equals alpha minus beta, right? So this is what we have from this illustration. Okay, and we are going to use this a lot. So let's consider this as equation 1, or let's do some trick informations here, right? So let's try to introducing theta, introducing sun to both sides, introducing sun to both sides. We are going to have sun of theta equals sun into alpha minus beta, right? You know this of, so you know of this, right? So here we're going to have sun theta equals, we expand this from straight identity, and this is going to be sun alpha minus sun beta over 1 plus sun alpha times sun beta, right? So this is what we have. And don't forget, in the beginning, we said that we are considering two lines, L1 and L2, and these two lines have gradients M1 and M2, but M1 is greater than M2, and these two gradients are greater than 0, meaning they are positive. So we're going to substitute M1 here, substitute M2 here, then we do the same thing at the denominator. So we're going to have sun theta equals M1 minus M2 over 1 plus M1 times M2, right? So this is what we have. So we consider this as equation 3, right? So this is the formula that we are going to use a lot. So tan theta equals M1 minus M2 over 1 plus M1 times M2. So this will help us to calculate the angle between these two lines. But there is another formula that it do come whenever we calculate the angle, and it's, if you are calculating an angle between two lines, then it must be an acute angle, right? It must be between 0 and 90 degrees, right? But sometimes, depending on the order of M1 and M2, we can have a negative value, right? So there is a standard trig and identity, there is a standard trigonometric identity that goes this way, that goes this way, right? That is, it says that tan into 180 degrees minus theta equals negative tan theta, right? So this is a standard trigonometric identity, right? So we consider this trig identity as well and fix it into this formula, right? So let me write it here. This is a standard trig identity, right? So basically this is negative. Okay, so this is the formula, but alternatively there is this formula where it goes this way: tan into 180 minus theta equals this m1 minus m2 over 1 plus m1 times m2 equals negative tan theta. Okay, so let me break it down to layman's ground, right? So we're going to have tan into 180 minus theta equals negative tan theta, right? You know, this is a standard trig identity, okay? And you know, tan is negative in the second quadrant. You know, in the second quadrant, it only sign that has a positive value, right? So basically the tan is negative, and this is because the tan is periodic and it is odd in the second quadrant, okay, where tan into 180 minus theta lies, right? So tangent is negative. So whenever you have, so that is why whenever uh, we have tan into 180, or yeah, into 180, basically this is what we have here. Tan theta equals m1 minus m2 over 1 plus m1 times m2, right? Here we have a negative here. Okay, here we have a negative here because of this. Okay, and this is happening because the order of the m1 and m2 can result you into a negative value. The angle that you calculate can be negative depending on the order of m1 and m2. So that is why, to avoid this formula, that is why I always say that make sure that m1 is greater than m2, and these two values must be greater than 0. Okay, so if maybe you position the value of m1 and m2, then there should be a negative value attached to your formula. Okay, so that is when we have tan theta equals negative into m1 minus m2 all over m1, 1 plus m1 times m2. So this is another formula that you can use. So basically, don't forget, if you are calculating for angles between two lines, look, it must be an acute angle. Basically, that is what they are known for. And acute angles are angles that lies between 0 and 90 degrees. Note that. So put it somewhere. It's very important. So whenever you calculate these angles, don't expect it to exceed 90 degrees or equal to 90 degrees. Never expect that. It should be between 0 and 90 degrees. All right, so let's take a problem to basically understand the whole concept that we just talked about. This is problem 1, okay? We want to find the acute angle. So in here, it has been stressed on that find the acute angle theta between the lines y equals 2x plus 1 and y equals 3x plus 2. So as I said earlier, angles between two lines must be acute. Okay, so let's begin the process. So let's illustrate the information on the diagram. You know, geometry is such a way that it's not abstract, okay? Everything we talk about can be illustrated. It's not like abstract. Okay, so we have our line 1 here, so L1, okay? And L1 has this equation. So we have y equals 2x plus 1, right? Now, this is our line 2, okay? Line 2, where we have y equals 3x plus 2, right? So this is our line 1, and this is our line 2, right? And we want to find the angle here, okay? We want to find the angle that is between these two lines. So what do we need? We need our M1 and we need our M2. So basically, to get your M1 and M2, what you need to do is compare this equation of a line to the slope intercept formula, right? So we have y equals ms plus c, slope intercept form, right? So this is what we are going to compare with these two lines to have our M1 and M2. So comparing, so let's say this is 1. So we comparing 1 with y equals 3x plus 2 and y equals 2x plus 1, then we're going to have comparing this, and this to this, then we are going to have our M1 equals 3 and our M2 equals 2. Don't forget, I always say that make sure M1 is greater than M2. So whichever way the question comes, whether this comes first or this comes first, make sure that when you are choosing the M1 and M2, M1 should be greater than M2 because we are taking M2 from M1. Okay, so we're going to have sin theta equals negative, equals M1 minus M2 over 1 plus M1 times M2, right? So we have the formula here. Just have to substitute M1 and M2, right? So we're going to have sin theta equals 3 minus 2 over 1 plus 3 into 2, right? So this is basically equal to 1 over 1 plus 6, right? So this is equal to 1 over 7. So what we just need to do is to take the tangent inverse of 1 on 7. So sin theta equals 1 on 7, right? And we want to know theta. We want to know theta, right? So theta will be equal to tangent inverse of 1 on 7, right? And this is basically 8.301, right? 8.301 from, so when you calculate this on your calculator, you have 8.1301, okay, degrees. Okay, so basically this is the angle that is between this line 1 and line 2. So the angle here is 8.1301 degrees. Okay, so that is interesting, right? So whenever you have two lines, okay, and you want to calculate the angle between them, this is the process. Let's continue to division of a line segment between in a given ratio. So we continue with division of a line segment in a given ratio. And basically, we are going to discuss the internal division and the external division. Interesting, right? So just have this in mind. Everything here is going to be practical, okay? Everything, we will graph it. We will graph everything for you to get the clear concept, okay? So we not just put the formula down, you know the formula. But why we are here is to derive the formula and make things clear. So that if you forget about the formula, you know that now this is the process that we went through to get the formula, and then you get it right away. So let's dive into it. So we want to begin with the internal division. Internal division. Okay. So we begin with the internal division. So with the internal division, this is the illustration that we are going to use. Okay. Let's say we have X and Y plane. Okay. And there is a line. So we have a line here. We have a line here. Okay. And this is A of point X1, Y1, and this is B of point S2, Y2, right? And we form a triangle here, okay? And we continue to form another triangle here, okay? That is it. And we decide to call this part, R of point X and Y. So this is the division. This is the division, okay? This is the internal division. This is the point that we are going to look for, R of X and Y. And this is the ratio, N is to M, okay? N is to M. And let's say this is called D and this is C, okay? And there is a point here, you know, from this is X1, Y1, and this is X, Y, and this is S2, Y2. So if you want to know this distance, then it's basically going to be S minus S1, right? X minus X1. Okay, and this is going to be Y minus Y1, and it must be absolute because it's a distance. And over here, we're going to have S here, and this is Y, Y2 minus Y. So it must be absolute, okay? It must be a positive value because it's a distance, okay? So we want to know this internal division, okay? So the point, we want to know the coordinate of this here. Okay, so we know that line AC is to line RD, right? This and this. Okay, AC is to RD. So we have R line AC, the distance AC is to RD, right? And they are in the ratio N is to M. Okay, so that is what we have. So this is here, it's basically X minus X1 is to S2 minus X. Okay, and that is equal to N is to M, right? So we just want to find the first coordinate of R, that is the X. Okay, so that is why we are talking in terms of the X. So we're going to have X minus X1 is to S2 minus X. Okay, and that is equal to N is to M, right? Because this is to this is equal to the ratio N is to M. Okay, so here we're going to have X minus X1 divided by S2 minus X equals N over M, right? So this is what we have. We want to find X, right? So what do? We spread this here and we spread this here. So we're going to have X into X minus X1 multiplied by M, and that should be equal to N into X2 minus X, right? So we're going to have mx minus x1 m, or mx1 equals ns2 minus nx, right? We are interested in the x, not the x1 and s2, right? So we're going to have mx plus nx equals mx1 plus nx2, right? So let's factor x out here. So we factor s out, we're going to have m plus n equals mx1 plus nx2, right? So we divide here by m plus n, divide here by m plus n, right? So basically this takes of this, we're going to have x equals mx1 plus ns2 over m plus n. This is the first coordinate for the internal division. So this is the s coordinate. Okay, so let's try to derive the y coordinate as well. So I don't want to erase this illustration because we are going to use the same illustration to find the y coordinate. So I'm going to erase this part. Okay, so we're going to have this off. So now we want to find the y coordinate. Okay, so with the y coordinates, you know that basically we can say that RC, right? Because we want the y coordinate, the y minus y1 and the y2 minus y1. So we can say that RC, right, distance RC is to this distance BD, right? This distance is to this distance, right? So we have BD. And that should be equal to their ratio. The ratio here is n, and the ratio here is m. Basically, this is this, and this is this, right? So we have n is to m, okay? And basically, this is what we have here. So that is y minus y1 is to y2 minus y, and that is equal to n is to m. Okay, so let's try to illustrate it here. Y minus y1 divided by y2 minus y, and that is equal to n over m. That is amazing. So we take this here and we take this here. So we're going to have m into y minus y1 equals n into y2 minus y, right? So we spread this here and we spread this. So we're going to have m y minus m y1 equals n y2 minus n y. We are interested in the y, so we bring this here and we send this there. So we're going to have my plus ny equals my1 plus ny2, right? So we are interested in the y, so we factor y out, having m plus n equals my1 plus ny2, right? So we are interested in y, so divide here by m plus n, here by m plus n, right? So we have y equals my1 plus ny2 all over m plus n. Wow. And that is the y coordinate for the internal division. So we combine the y coordinate and the s coordinate, and then we have the division of a line segment in a given ratio. If you want to find the division of a line segment in a given ratio, that is in the internal division. Okay, so basically, now we can erase our diagram. So now the internal division formula, is given as s comma y, that is the point of r, s comma y equals r of the x was m x1 plus n s2 over m plus n, comma, the y is also my1 plus ny2 over m plus n, right? So that is it for the internal division. So whenever you want to calculate the internal division, this is the formula, okay? Okay, so this is mx1 plus ns2 over m plus n, and my1 plus ny2 over m plus n. Okay, so note this formula down. That is for internal division. This is the x coordinate and this is the y coordinate. Don't forget, that is the formula for the internal division. And you know the process of getting the formula. So you don't have to memorize this. This is geometry. Everything is practical. Okay, so let's move to the external division. We continue with the external division. Now, let's have a line. Okay, this is our line. Let's call it AB, right? And there is a line that is dividing x a and b externally. So this is our external division, C. In the previous one, it was internal division, right? So that was easy, right? So this time, this is this C is dividing AB externally, right? So now let's try to note something here. So this is the external division, and in the ratio n is to m, right? So we have this is our bigger ratio, that is the m, right? Now we want to know, so we call this one x1, y1, and call this one s2, y2. This is the x and y. Okay, C is dividing AB externally. So in the ratio n is to m. So this m is for the whole distance, and this n is just for this part, right? The BC. So that one is covering this part for the n. I hope that is interesting, right? So now let's try to calculate the x coordinate and calculate the y coordinate as well. So let's begin. You know that we want to concentrate on the x coordinate first. So with the x coordinate, we know that AC, right, line AC, that distance AC is to the distance BC, right? BC will be equal to m is to n, right? The distance AC is to the distance BC will be equal to m is to n, okay? So let's try to, in terms of x, so this is going to be s minus x1 is to this, and this is going to be x2, x minus x2, right? Is equal to m is to n, right? So here, we come down here, we're going to have x minus x1 over x minus x2, and that is equal to m over n, right? So we're going to have n into x minus x1 over that is equal to m into x minus x2, right? So let's try to spread the n and the m throughout the information there. So we're going to have nx minus nx1 equals mx minus mx2, right? And this, we are interested in the x, this and send this here. Okay, so we're going to have ms2 minus nx1 equals mx minus nx, right? So in other words, we can say that mx minus nx equals ms2 minus nx1, right? So we factor x out, so we're going to have x into m minus n, and that is equal to m s2 minus nx1, right? So we divide here by m minus n, divide here by m minus n, right? So this goes off. I'm going to have x equals mx2 minus nx1 over m minus n, right? So this is the first coordinate for this external division, C of x and y. So this is the x, right? Now let's go ahead and find the y coordinates, right? So this is the process for obtaining the s coordinate of the external division. So for the y coordinates, the same ratio, right? AC. So AC is to BC, right? And that should be equal to M is to N. But this time around, we are interested in the y coordinate, so we talk in terms of y. So we're going to have y minus y1 is to y minus y2. And that should be equal to m minus m divided by n, right? So now we can erase the diagram, right? So this goes off. So we have y minus y1 divided by y minus y2, and that should be equal to m over n, right? So we have n inside, y minus y1 equals m into y minus y2, right? So we're going to have ny minus ny1 equals my minus my2, right? So we are interested in the y coordinate. So let's bring this here. So we're going to have my2 minus ny1 equals my minus ny, right? So in here, in other words, we can say that my minus ny is equal to my2 minus ny1, right? So we factor y out, I'm going to have m minus n equals my2 minus ny, right? So we come up here and we're going to have y into m minus n equals my2 minus ny1 here. So we divide by m minus n here by m minus n, right? So we're going to have our y coordinate to be equal to my2 minus ny1 over m minus n, right? So this is how we obtain the x and the y coordinates. Now let's combine them. So the coordinates of C, which is x and y, is equal to C of mx2 minus nx1 over m minus n, comma, my2 minus ny1 over m minus n. That is amazing. So we have been able to derive the formula for finding the external division of a line in a given ratio. The external division of a line segment in a given ratio, and that is C of x and y is equal to C of ms2 minus ns1 over m minus n, comma, my2 minus ny1 over m minus n. So this helps you to recover yourself whenever you forget about the formula. You know how to derive it. So that is not a problem at all. So now let's consider a problem to basically clarify the whole concept. So this is problem 1, okay? We want to find the point dividing the joint of A of 1 and 2 and B of 3 and 1. And A, we want to find the internal division in the ratio 1:2. B, externally in the ratio -1:2. Okay, so let's begin. So with the first one, A, internal division of line A of 1 and 2 and B of 3 and 1 in the ratio 1:2, right? We are letting C of point X and Y be the points of this internal division of line A and B. Okay, so this is the point that we are going to look for. Now, we don't have to derive the formula again. Now we know the formula, so we're just going to apply, right? So we know that for the internal division, of C of X and Y is equal to C into mx1 plus nx2 over m plus n, comma, my1 plus ny2 over m plus n, right? Okay, so basically what I want you to understand is that whenever they give you the ratio, okay, 1:2, okay, do this. This is basically what it means. This is basically what it means. You know, we have been given points A and B, and in the ratio 1:2. And the ratio, this is how it is done. N:m, right? That is equal to the ratio, okay? So 1:2. Okay? And the same way we did to derive the formula, you know that this is n over m, right? And that is equal to 1/2, right? So basically, if you want to know how we do it, this is to this and this is to that, right? So we have 2n equals m, right? So if you want to know the how the process goes, then this is how you do it. So this is basically telling you that m, the value of m is 2, right? Because m is equal to 2 times n, right? And so n is equal to, in other words, n is equal to 1, right? So that is basically the understanding of the ratio. Once you are able to identify the ratio, then you are good to go, because that is the only thing that I think it will be a problem, right? So this is how you do it to get your ratio. Okay, so now let's go. Once we know the ratio as m equals 2 and n equals 1, then we can go ahead and do the work, right? So we have A of 1 and 2 and B of 3 and 1. So we can identify our x1, y1, y2, y2 from this point, right? So this is our x1, this is y1, this is s2, this is y2, right? So we do that substitution, and we're going to have our C of m is 2 into x1 is 1 plus n is 1 of S2, which is 3, right? Over m plus n, which is 2 plus 1, comma, m, which is 2, into y1, which is 2, plus n, which is 1, into y2, which is 1, over m plus n, which is 2 plus 1, right? So we have our coordinate of C to be 2 plus 1. 2 into 1 is 2, plus 1 is to 3 is 3. So we have 2 plus 3, and that is 5 over 3. And this is 4 plus 1 is 5 over 3. So this is the coordinate for C that divides AB internally. So that's the coordinate of C that divides AB internally, in the ratio 1:2 is given above. Very simple. C of 5 on 3, comma 5 on 3. So that is for the internal division. Let's try to do the external division. The same point, but this time round is -1. The ratio is -1:2. So how do we do this? So the external division, so do you think we are going to use this negative? Right? Maybe decide on that before I start. Okay, so with the external division, we know that we have point of A, which is 1 and 2, and that of B is 3 and 1, right? And so let me clear off the A and shift this up, right? So the B, which is the external division, right? 1, 2, and B of 3 and 1 in the ratio -1:2, right? So I'm going to do this perfect. So you know that let's also use the same C. Okay, so C of X and Y equals C of the formula, right? mx1 minus nx2 over m minus n, comma, my1 minus ny2 over m minus n. So here, in this ratio, -1:2. So this is basically telling us that the -1, this AB is moving, the first ratio, which is -1, is in the negative direction, is moving in opposite direction, right? So that is why it's negative. But that doesn't mean we are going to use the negative in our calculation. Take note. Whenever you have a ratio, negative ratio, that is telling you the direction of the line. but it doesn't mean you're going to use the negative in your calculation. Take note, because we are talking about distance, and distance is not negative. It can never be negative. Okay, so we have understood that the negative here is telling us direction. Okay, so here we're going to do the same thing to know the n and the m. So we've understood that the negative is just showing direction. So we are not going to use the negative in our calculation. So we know that m is equal to 2 and n is equal to 1, right? So here we know that this is x1, this is y1, and this is x2, y2, right? So we have the coordinate of C, that is x and y, equals m, which is 2, right, of x1, which is 1, minus n, which is 1, into x2, which is 3, over m minus n, which is 2 minus 1, right, comma m y1, and that is going to be 2 into y1, which is 2, minus n y2, and n is 1 and y2 is basically 1 as well, all over 2 minus 1, right? So we're going to have c of x and y equals c of 2 times 1 is 2, minus 1 times 3 is going to be 2 minus 3, over 2 minus 1 is basically 1, comma 2 times 2 is 4, right? So we have 4 minus 1 times 1 is 1, over 1, right? So we have c of x and y equals c of 2 minus 3 is negative 1, over 1, comma 4 minus 1 is 3, over 1, right? So we're going to have the coordinate of c to be negative 1 and 3. So that's the point that divides line AB externally in the ratio negative 1 is to 2 is given above. Right, so take note. Let me stress it again. Whenever you have the ratio negative is to something, negative ratio, consider it to be positive because we don't have a negative distance. Don't forget, when we are talking about this information, we are talking about distance. Okay, so don't forget we don't have a negative distance, so we don't use the negative here. Omit the negative. The negative is showing direction, but it doesn't mean you should use it in your calculation. So that is the process. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and comment as you watch. And until the next video, keep learning and stay inspired. Bye-bye.